When acquiring data, transducers are usually mounted at each point on a structure such that the X, Y and Z directions are the same. In other words, each point shares a common global axis. This allows acquired data to be compared easily, for example, measuring the displacement at each point in a single direction. In some cases, it is not easy to mount a transducer at the same orientation as another, and a special mounting is required. Alternatively, STAR7 has a number of methods which allow you to define unique axes for each point, i.e. a local axis. The software will then automatically allow the data to be displayed in terms of a global axis. There are some conditions. If data at a single point is measured along 3 axes, then it can be reorientated in any way possible. If it is measured along 2 axes, then it is only possible to describe the data across that plane. Data measured in a single axis cannot be reorientated. When setting up the model, it is important that the local point axis matches the orientation of your transducer. The point axis can be displayed by right-clicking a point and selecting Point Axis. Using the Model Setup window, select View, Point Axis. For each point, there are 3 main types of local axis: Model, Component and User-defined. The default is Component. When Component is selected, the local point axis will depend on the coordinate system and any rotation applied to the component. The default settings are a rectangular coordinate system and a 0 rotation, so the component axis will match the model axis, i.e. the global axis. If a cylindrical or spherical coordinate system is used, then the local point axis will depend on the theta or phi angles for each point. The component rotation will then be applied afterwards and affect each point the same. User-defined point orientations can be applied to one or more points. These orientations are applied using the component axis as a starting point. Using the interactive editor, the local axis for groups of selected points can be adjusted visually with ease. Once the local axis for each point is correct, the model can be used as a guide during acquisition for correct placement and orientation of the transducers. Data is acquired in terms of a local axis, but once the data is analysed, the modal parameters can be displayed in terms of its original local axis or the global axis. For further information on our wide range of vibration control, data acquisition and analysis products, please visit our website at www.spectraldynamics.com.